Yeah, so welcome to Mwalimu Ignatius Wahome YouTube channel for mathematics subject. And today's lesson, I'm going to cover Form 4 mathematics. This is the Kcse 2025 revision for candidates. And I have picked a question on differentiation, a question that was provided Kcse 2021. So that's a 10 marks question. I would like us to see what was tested in the Kcse 2021. So therefore, let's see the question provided here. So the question is here. The question. Now, Kcse 2021. This question was question number 24 of Kcse 2021. So you're given the equation of a curve is given as y equals to a third x cubed minus a half x squared minus 2x minus a third. So in question A, the first question, we are told find Roman 1, the value of y when x is negative 2. That question was 2 marks. This is 2 marks. It is 2 marks. I want us to see. So what are you supposed to do in this question? You find the value of y when x is 2. When x is negative 2. In this case, you are supposed to substitute. You get y when x is negative 2, a third, negative 2 cubed, minus a half, x squared, negative 2 squared, minus 2 into bracket, negative 2, minus a third. That's how you find the value of y. That's how you find the value of y. So you substitute this. Negative 2 cubed is 8, negative 8. So negative 8 over 3 minus 2 squared, negative 2 squared is 4 times a half, that's negative 2, minus 2. Then 2 times minus 2, that is minus 4. So minus, and minus a third. Want us to get y. So this would be minus 8 over 3, minus 2, plus 4, because there's a minus and a minus, plus, then minus a third. So that's how you did it. So you can put this one direct in the calculator and put minus 8 over 3, minus 2, plus 4, minus a third. Minus a third. In this case, you get the value of y is minus 1. So therefore, when x is negative 2, the value of y is minus 1. So that's what you get. That's what the examiner is testing. The first question, A Roman 1. And let's go to Roman 2. Let's go to Roman 2. Let's see. So that was now B, the question B, or the same question. So this question is find Roman 2, the equation of tangent to the curve at the point x equals to negative 2. This question is 4 marks. That question is 4 marks. Let's see what again is tested here. Kcse 2021. So this is part of the Kcse 2025 revision. The equation of tangent to the curve at this point. So this one, at the point x equals to negative 2. In Roman 1, we were told we find the value of y when x is negative 2. Y is negative 1. So it is the same point because x is negative 2. So therefore, you take this point, negative 2, negative 1. That's a point. So what do? You are supposed to take this equation y equals to a third x cubed minus a half x squared minus 2x minus a third. That one there. When you have that one, you are supposed now to find the gradient function. You are supposed to find the gradient function for this. And the gradient function for this one is the one that we say dy over dx. You differentiate this function. So when you're differentiating this power, you're supposed to drop this power there. You get 3 times a third. Then this power decreases by 1, becomes 2. It was x squared. It was x cubed. It is x squared. Minus a half. This is 2 times a half. This was x squared. Now becomes 1. Minus this was 1 times 2. Just 2 like that. So you simplify this by 3 and by 2. So that you get your dy over dx is equal to x squared minus x minus 2. So the gradient function, which you are supposed to get, dy dx is this one, x squared minus x minus 2. That's the question. X squared minus x minus 2. That's the gradient function. And now since you're told you find the equation of tangent, first of all, we need to understand what's a tangent. A tangent is a line touching this curve at only one point. Assuming our curve looks like this, we just assume it looks like that. This curve at this point is this is the tangent. That's the tangent. A line touching this curve, this is the curve. The tangent is that line touching that curve at only one point, and the point is negative 2, 1. So what you should know that is that the equation, the gradient of the curve at this point is equal to the gradient of the curve of the line of the tangent at the same point. So therefore, you're supposed to find the gradient of this curve at this point, which is equal to the gradient of the tangent. So therefore, you say dy dx or dx, which is equal to x squared minus x minus 2. You are supposed to substitute x is negative 2. Negative 2 squared minus negative 2. X is negative 2, then minus 2. We see what's the gradient. This is 4. Minus the minus comes to plus 4. Minus 2. 4 plus 4. 8 minus 2. That is 6. So the gradient of the tangent is 6. The gradient of the tangent is 6. So therefore, what is the equation of tangent? So take this point, negative 2, negative 1. Take an arbitrary point xy, and then this gradient, 6. The gradient of the tangent, which is 6. So now you find the equation of straight line. The same way you find the equation of straight line, because a tangent is a straight line touching that curve at only one point. So you say y minus 1 all over x minus 2 is equals to 6. You get that? So this is minus the minus comes to plus. So therefore you say y plus 1 all over minus the minus x plus 2 is equals to 6. Is equal to 6 like that. Equals to 6. You now need to find this is the equation of tangent you're looking for. So you can multiply both sides by x plus 2 and x plus 2 on this side. Multiply both sides. So therefore this x plus 2 cancels this. You are left with y plus 1 is equal to 6 bracket x plus 2. Open that bracket. Open that bracket. You get y plus 1 is equal to 6x plus 12. Y plus 1 is equal to 6x plus 12. You take this plus 1 to the right. This you get y equals to 6x plus 12 minus 1. You want to find the equation of tangent. We are looking for the equation of tangent in this case. The equation of this tangent. So it is 12 minus 1 is 11. So y is equal to 6x plus 11. And this is the required answer. NS. That's the equation of tangent at this point. So that is the required equation of tangent. And you should always note that the gradient of the curve is equal to the gradient of the tangent at the point of contact. This point. So that's what the examiner was testing in the Kcse 2021. So there's a similar question that can be tested in the Kcse 2025. And this topic, differentiation, is one of the most examinable topic in paper 1, mathematics, differentiation. So this is one of the topics that students need to cover all of this. So that's how to cover the that equation. So the equation of tangent to that point. So you find the dy dx, then you substitute x is negative 2. Get the gradient is 6. Then you use this negative 2, negative 1, and xy. Y minus 1, x minus 2 equals to 6. So that's what you do. You find the equation. That's the equation of tangent. That is part A, Roman 2. I want us to see Roman 3. It was a question on finding the turning point. Let's see. How do you find this? Yeah, so that's a question, Kcse 2021. Now in part B, another 4 marks. It's another 4 marks. So you can see that's a Kcse question with the 10 marks question. So the next step is the second, the third question for that. That's part B. Determine the coordinates of the turning points of the curve. 4 marks, nothing else. 4 marks. So the key word here is turning point. The turning point. So the turning points, they are also called the stationary points. Call them also the stationary points. In this case, at turning point, dy over dx is always equal to 0, the gradient function. So in this case, you differentiate this, or the one that we had differentiated, equated to 0, we had differentiated this. If we differentiate this, dy over dx, in part Roman 2, we had got x squared minus x minus 2. That was a dy dx. X squared minus x minus 2. But if you differentiate, you still get this. You are supposed to take this function x squared minus x minus 2, equate it to 0. That's what you do, equate it to 0. For you to solve this equation, for you to find the turning point. So in this case, now, you apply the knowledge of quadratics in form 2. You can use quadratic form 2 to solve this product method. A is 1, B is negative 1, and C is minus 2. So therefore, you use AC, product AC, 1 times negative 2, that's negative 2. And then the sum will be equal to B, which is equal to negative 1. Equals to negative 1. So therefore, we are using sum and product method. So in this case, you want to solve this one by factorization. So two numbers you multiply, you get minus 2. That is the product AC, and the sum equals to B negative 1. Two numbers you multiply, you get minus 2, and you add, you get minus 1. That is minus 2 and 1. Those are the two numbers. If you multiply this, negative 2, 1. Negative 2 times 1, negative 2. Negative 2 plus 1, negative 1. So that's what you do. Then from there, you now, instead of writing negative x, you take these two values. You say x squared minus 2x plus x minus 2 is equals to 0. Because that one now, you have already formed an equation. 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 So that's what you get. That's what you get. So therefore, these ones you factorize now. You factorize by grouping. You group the first one, and now the second one. The first group, what is common? X is common. Then you get x minus 2. The second one, x minus 2 plus 1 is always a common factor in all the numbers. So you put plus 1 to get x minus 2. So plus 1 is a common factor. You are supposed to put it like that. Plus 1 is a common factor. So therefore, take this x plus 1, and then x minus 2. Factorization, equated to 0. You want the coordinates of the turning point. Coordinates of the turning point. So you find the value of x. Then once you get x, you have to get y. So take this x plus 1 equals to 0. X plus 1 equals to 0. Or x minus 2 equals to 0. Take this on this side. X is equal to negative 1. Or x is equals to 2. Positive 2. So that's what you do in that question. Now you already have the value of x is negative 1. Or x is equal to 2. Or x equals to 2. Remember, this is Kcse 2021. And we are using this question to revise for the Kcse 2025. This question, x equals to negative 1. Or x equals to 2. So therefore, you find y now. Find y. So when x is negative 1, when x is equal to negative 1, your value of y will be equal to a third. X cubed, negative 1 cubed, minus a half into bracket, negative 1 squared, minus 2 into bracket, negative 1, minus a third. Now you get the value of y there. This way, now you get the value of y in this question. You're supposed to get the value of y in this question. When you have substituted, when x is negative 1, what is y? So this becomes negative 1 cubed is negative 1 times a third, that's negative a third. Minus negative 1 squared is 1 times a half, that's a half. Minus 2 times minus 1 is minus 1, minus 2. So minus 2 becomes plus 2, minus a third. You can do that one directly using the calculator. Say right minus a third, minus a half, plus 2, minus a third. You can put them direct. you get this is 5 over 6. That's 5 over 6. That is 5 over 6. So therefore, one of the point, y is 5 over 6. So therefore, meaning one of the turning point is when x is negative 1, then y is 5 over 6. That's a turning point. That's one of the answers. That is one of the answers. When x is negative 1, y is 5 over 6. That's a turning point. So negative 1, 5 over 6. Then you say when x is 2. When x is 2. So what do you do when x is 2? When x is 2, again now, you substitute the same equation, y is equal to a third, x cubed, 2 cubed, minus a half, 2 squared, minus 2 into bracket 2, minus a third. You won't find the second value. So this is a third. 2 cubed is 8 times a third, that is 8 over 3. 2 squared is 4 times a half, that is 2. Minus 4, 2 times 2, minus a third. Again, when it is addition and subtraction, you can just put them direct in the calculator. 8 over 3 minus 2, minus 4, minus a third. And then this one becomes minus 3, 2 over 3. Minus 3, 2 over 3. So that is the second value for y. So therefore, the other turning point will be when x is 2, y is negative 3, 2 over 3. So therefore, you have this turning point and this other turning point. So therefore, in this case, this question part B, the examiner was testing whether the student knows how to deal with the turning point. And the turning point is a major concept there. That's a major term in that question. The turning point, dy dx equals to 0. And sometimes can be used this word, stationary point. Stationary point. So if you see the word stationary point or the turning point, meaning the gradient function at that point is equals to 0. Equals to 0. So that is how you solve quadratic, then you substitute. And that is Kcse 2021, question number 24 on paper 1, mathematics. So therefore, revise this kind of questions and follow this YouTube channel for more past Kcse questions so that it will help you to do Kcse 2025. So thank you very much for listening to this lesson from Mwalimu Ignatius Wahome YouTube channel. So remember to subscribe and also recommend other students in Form 4 to follow this channel, even in your class or even in other schools. Please refer them to this and they learn a lot of mathematics. So thank you very much for that lesson.